Today we're going to look at the Bohr model of the atom, and it is important to understand that this is simply a model. This is not what the atom actually looks like, but it helps us to understand the atom a little bit better, as well as the particle nature of light. So the model looks something like this. We have kind of our nucleus, which, if you remember, we have things like neutrons and protons in the nucleus, and then we have these different energy levels that surround the nucleus where we can find our electrons. Okay, so let's go ahead and draw out 3 levels out here. All right, and so the electron can basically be in any of these various levels. Actually, I drew it in the nucleus. That's wrong. So it can be in this first level, second level, third level, etc. And what it will not be found is anywhere in between. Okay, so we can only find it in level 1, 2, 3, or however many there are. Now what will happen is if we shine some light on this, let's say we shine some light on this atom, okay, this electron or this atom can absorb that energy. If it absorbs that energy, the electron can move up into a higher energy level. Okay, so this is a lower energy level. If it absorbs more energy, it moves up into a higher energy level. Likewise, if this electron, so in this case it's going up, likewise if this electron drops back down, it will now lose energy, goes from higher to lower energy, and then it will release a photon. It releases that energy as well. Okay, so another example would be, let's say our electron's down here in the bottom state. Let's say it absorbs another photon, comes in. Okay, that electron gets kicked up to a higher state. Okay, now this electron could come all the way back down, in which case it would release that same exact photon here, but it could also go down here first, release a photon, and then drop back down again and release another photon. Okay, in this case that one photon comes in and you end up with these 2 photons that get released as this electron goes back down. Okay, by the way, the colors I used here, I'm noticing, are incorrect and wrong. So I want you to think about why that is. When you get to the end of the video, why don't you think about why that is? Why are those colors incorrect? Alright, so we usually don't draw it as a circle like this. Oftentimes we draw it as simple straight lines. So for example, let's go ahead and draw one out. Let's say this is our nucleus, okay, neutron, protons down here. And in fact, we usually don't even draw that. We just draw these energy levels. So this would be the bottom state. I'm just going to draw a hypothetical here. Let's say this is negative 20 electron volts. And we'll talk about the negative in a second. Let's say this is negative 14. And let's say this is negative 10. So we'll just draw 3 levels here. This is what's called the ground state. This is the simplest state, and this is the state that electrons will always tend towards. So if it jumps up to a higher energy state, it's eventually going to reach its way back down to the bottom, whether directly or indirectly. So the top, if we go all the way up here, this would be the 0 electron volt level. And essentially at the top, once the electrons reach this level, it's escaped or been ionized. So it's been liberated from the atom in that case. All right, so let's look at let's just do a simple concept here. So if I send a photon in, okay, let's say I send a photon in here. So this electron, let's say this photon happens to be exactly 6 electron volts. Okay, now this is at the negative 20 state. To go up here, the difference between these 2 states is 6, right? So if we send in a 6 electron volt photon in, this atom can absorb that, and this electron is going to jump up to a higher energy level. All right, now notice we went from negative 20 plus 6 got us up to negative 14. So it's absorbed that 6, negative 14 is a greater number than negative 20, and so it has now been excited. We'd say it's now in an excited state. Note, just important note, if you sent in 5 electron volts, let's say you sent in 2 photons, 5 and 1, those 5 and 1 would just pass on through, so they don't add up to each other. It would only a 6 electron volt will, this will only be able to absorb the 6 electron volt to get it up to this level. So in other words, you can't find an electron in between levels. This is what we call a quantized state, so it can only be in these discrete levels. So anyways, this electron, if it relaxes back down, okay, in this case, if it relaxes back down, it's now lost energy. And since we know energy cannot be destroyed, that energy then gets released as a photon. And since it lost 6 electron volts of energy, it's going to release a 6 electron volt photon. Okay, now other possibilities, we could send in another photon. Let's say this photon is 10 electron volts. Well, if we sent in a 10 electron volt, this atom could also absorb that. In this case, this electron would go all the way up to this higher state. Because the difference between, if it absorbs 10 electron volts and it's at negative 20, it can be kicked all the way up to the negative 10 level because it's added 10 electron volts of energy. Okay, so that would be 10 electron volts there. So let's say then, instead of dropping all the way back down, if it dropped all the way back down, it would release another 10 electron volt photon. But let's say instead it drops to this level right here. So if it drops down to this second level, well, in this case, it's going to lose 4 electron volts of energy, 10 to negative 14. So it's going to release a 4 electron volt photon. And let's say then it now drops from this level back down to here. It would again release a 6 electron volt photon as well. So in this case, 10 comes in and it would release a 4 and a 6. So notice these two energies, we're talking about conservation of energy here, these two energies must add up to that 10 electron volts up here. Okay, so I think that's about it. I'm going to go ahead and stop here. Back to my original question, or kind of question to think about. If you have these different colors, I want you to think about, okay, based on what I did here, actually let's just do it with these, do it with this. Based on what I had here, I got red, I got orange, I got yellow, I got blue. Based on what you know, what would be a proper use of the colors? Okay, just conceptually, which would be the proper use in the various situations I thought about. So think about that, and then I'll go over that in class tomorrow.